Hi everybody, Bus Jockey here again today. Today I'm going to do another video demonstration of the Loadpro, a little bit more advanced testing, what you can do with it. First thing I'm going to do is I'm going to explain again the ghost voltage and true 0 volt diagnostic method that Dan Sullivan uses with his training and shows in his fundamental electrical troubleshooting book, which is a good read, by the way. Need to pick it up. So anyway, let's get started. I'll start off with the simple stuff, and then I'm going to give everybody a very good explanation on how the Loadpro actually works. So let's get started. Alright, first of all, with ghost voltage. Ghost voltage is basically it's the meters reacting to outside forces. It's getting currents induced into the leads, okay? And basically you could get it from lights, from wall outlets. You could another way to think about it is it also comes from the Earth's magnetic field, because magnetism creates electricity and it interferes with things. So these leads are kind of acting like a big antenna. So you're waving it around, and the meter readings, I'm shaking my leads, see? The meter's jumping all over the place. See, the bar graph's going crazy, and it's not staying steady, okay? So if you go up to a connector, like say I'm going to use these two wires as an example for the circuit and the connector, okay? This wire here, the green, connected to ground. This red wire here connected to the positive lead. Okay, so if you go up to a load connector disconnected, and you go in there and shake them a little bit, and the reading just keeps on jumping around all over the place. As you can see, I'm shaking the leads, and the bar graph's going nuts, and the reading's not staying steady. So if you see that, you got an open circuit, okay? And what you do is to isolate the problem on which side the open is in. You would then take your black lead, go to a good ground, repeat your test in the connector, and then if you saw system voltage, then you know that the problem is on your ground side. If the problem still stayed the same, then that means the open is on the positive side. And then in that process, probably the first most likely thing that I would check, I would then go to the fuse and see if the fuse blew. So that's what I would do. Now, say for example, you go to a load connector and you see straight zeros on your meter. This right here. If you see straight zeros and you're at the load connector with your positive and negative lead on each pin of that connector, and you see straight zero, that means you have a short to ground, because somewhere in the circuit the positive end of that wire at that connector is touching to ground, okay? Therefore, you are reading continuity through these meter leads. The positive is touching ground. It's going through the whole ground section of that circuit, coming back into your black lead, completing a path showing zero potential, and that means you have a short to ground. Now, another helpful way is you can also use the voltmeter function as a continuity tester. So if you wanted to check a wire, you could use this way also. So you go to the end of each wire like you would do in an ohm meter test. You could do this, and if you saw straight 0, then you know you've got continuity in the wire. It's not broken. Doesn't mean it can't. It doesn't mean though that it can carry a load, but it does tell you that the wire's connected at least. Okay, so that's true 0 voltage. Now, or one more thing before I go any farther. Another thing I like to do is I like to wiggle the leads around, and if it stays on true 0, it doesn't go anywhere. That's just another it's another way to confirm that you do have a short. I'll shake them around and make sure it doesn't move, and as you can see, I'm shaking this and it's not moving. Okay, so now so that's ghost voltage and true 0 voltage. Now the last part of the test, if you're in the connector positive and negative, and you read full system voltage, oh shoot, sorry, I'm just trying to get my other lead connected here. Alright, so if you go into the connector, positive, negative, and you've got full system voltage, this tells you two things. One, you don't have an open circuit, and two, you don't have a short to ground, so you're good. So then the last step would then be to push the Loadpro button, put a load on the circuit, and see if the wiring can take a load. So I'm going to push the button. As you can see, it dropped from 13.16 to 1302, 1299. That's good. Okay, you're going to have a little bit of drop. I'm going to take that off. There you go, and it goes back up. You're going to have a little bit of drop when you push that button. That's normal. That's indicating to you that you've got current flow through the circuit. Okay, what you're looking for is big drops, like over for like a 12 volt system over half a volt, a 24 volt system over a volt, and then the higher voltage drops. That's well, that's for starters and alternators. That's different. I'll go into that another time, but for right now, for this, for using these on like a 12, you want to look for like half a volt. 24 volt system, you want to look for a volt drop at max. So anyway, that's the main or the basic application of the tool and the diagnostic method that Dan Sullivan uses. Okay, so now what I thought I would do is I would also show you some different meters to show you the differences between them. A lot of them are the same. The only thing you got to watch out for is when you first turn the meter on, see what the default setting is. Like, see if it starts out in millivolts or a thousandths of a volt resolution, because that's going to change your ghost voltage sensitivity. Okay, so I'm going to show you some other meters here, what they start out at, and just to give you an idea that the ghost voltage and the true 0 voltage reading works on any meter. Okay, it'll work on any meter. It's just you got to know on what range to dial it in to get it to work. So I'm going to show you that. I got another meter here. I've got a Matco. It's a MD Tech Plus. I'm going to shut off the 589 meter, and I'm going to plug it into the Matco one, and I'll show you. I'm going to disconnect my ground here so I can show you what it starts up on default. Let me plug it in. Alright, turn it on. Alright, and as you can see on this meter, it starts off in the millivolt range, okay? And see how the ghost voltage, it's jumping all over the place, okay? So this one, you know, works the same way. Wiggle your lead around, you get ghost voltage, it goes all over, okay? Then if you touch the leads together, see? 0, 0, 0, 0. Wave the leads around, ain't moving, short to ground, okay? Works the same way, and then you'd read voltage and load the circuit the same way, okay? That's a Matco. That's the range that it starts out in, okay? Alright, next meter. I've got a it's a $20 special from Walmart. It's a Innova, and for the price, not that bad. Except it's not the amp settings are not fused, so you have to be careful. Don't want to ruin this by not putting a fused jumper in line with it. So, but anyway, as you can see on this one, let me get it plugged in. Okay, it works the same way, okay? Wiggle the leads around, ghost voltage all over, okay? Touch them together. See? 0, 0. Means you gotta short the ground, okay? Works the same way. Next meter, Fluke 87. Get it plugged in. Alright, now I want you to pay attention on this 87 and see what the voltage, or the what the default setting is for voltage. So I'm going to go to DC volts, and if you look, this one's different. Every meter has a different default setting that it goes to on auto range. On this one, it's 1/1000th of a volt resolution. However, the ghost voltage still works pretty good, okay? See? Wiggle it around. Readings going all over the place, okay? Touch the leads together. .000. Wave around. Doesn't move, okay? Alright, now I've got a manual ranging meter. I've heard people ask questions before about, well, you know, not me, but other people like Dan Sullivan. Will it work on a manual ranging meter? And the answer is yes. The only thing you got to do is when you start out to check voltage, you want to start out on the millivolt scale. And this one here is an Actron. It's a manual ranging, so you'd want to go to the, it's right there, 200 millivolt scale. Okay, I'm going to turn it on. You're on millivolts, and let me plug it in. Alright, now I'm waving my leads around. See? It's going all over the place. Works fine on a manual ranging meter. You just got to start it off on the lowest setting. I'm going to touch the leads together. They're together. Okay? And 0, 0. You got a short. Works the same way. Now, I've also heard questions before. Well, will I damage my meter if I go to a higher voltage? No, you won't. It's protective. It's protected from that. What the meter will say is it'll have two different abbreviations. It depends on the manufacturer of the meter. Some will say OL, which means out of range, and another one will give you a number 1 indicating you are out of range. So I'll illustrate that to you. I'm going to go hook this up to negative and positive on the jump box here. And there you go. I connected it, and you've got a 1. So then all you got to do is to figure out, what range you're in, you just go up 1. Another thing to think about it is, since you're hooked up to this right now and you get that number when you're checking out a load connector, that tells you right there you don't have an open or short, that you've got something. So you then just go up another range until it gives you a reading. And I went to the 20 volt scale, okay, and you're reading 13.11 volts. So it's not that hard. Just go on the lowest setting, go into the connector. If you then see a 1, which is the over range, just go up to the 20 volt scale to see what you got. And then you hit the Loadpro button. Voltage dropped. Just a little bit indicates your wire's good, and you're good to go. That's it. It works on a manual ranging meter just fine. Just have to go about it a little bit different, that's all. Okay? And now, what I think would be really cool to show you, I have a snap-on Vantage. And I'll hook that up to this. It can work on a Vantage. Heck, it'll even work on the brand new Vantage Pro. It'll work on any scope, really. So let me turn on the scope here, and then I'll get it connected. Hopefully you can see this pretty well. I gotta go to multimeter. There we go. Alright, I'm on auto ranging. And as you can see, I'm wiggling my lead around. And I'm on auto ranging. On this Vantage, it starts out on the millivolt scale. So it's going all over the place, see? All over. Okay. Then when I touch them together, this one's a little bit different on the 0 volt indication, though I will admit. Either that or it might be a little bit out of calibration. But it is showing 0, but then when you get to the next digit, it's a 0.3. But what I have learned is when you wave these around, the reading doesn't move. See, I'm moving it and I'm moving it, and it's not moving. So it's showing you 0 volt, but on that last digit, it's not going to 0. So I don't know if it's calibration or what. It could just be normal for this meter, but you can still use this as a 0 volt short indication. You just have to know that. On the newer models, I'm not sure, but the concept or what I'm trying to say is the concept will work on any meter. Once you learn how to do it and you practice, it can be done. You can learn it. It works. Now that I think about it, why don't I try doing reset here on my min-max values and see if that helps any. Well, for the to see the 0 volt. Nah, it's about the same. But as you can see, I am shaking it with the leads together, and it's not deviating from this reading right now, the 0.3 and then 0.0. So it does work. It's not deviating from this value, which that's good. So another way I can show you the ghost voltage is I can go on graph mode here. Go to view, graph. Alright, now I'm on the millivolt scale right now. Here it's not it doesn't auto range on graph, okay? But as you can see right now I'm on the millivolt scale on the Vantage. I'm going to take this lead and start plopping it around. If you notice, see all that noise? Okay, that's the ghost voltage. That's the interference you're getting. Okay, so you could use your graph function too to make sure that you got a good connection, and it also helps you look to see if you've got an open or not, you know, when you're checking out a load connector. Okay, then another thing, if I'm going to put the leads together, and if you notice, I've got the leads together again. It went away. See, there's the noise, and now I've got a flat line. And then I'm wiggling it. I'm shaking it. Lead together. Both leads touching. I'm shaking it, and look at the line. The line, it's not fluctuating. You're not getting any spikes. So if you wanted to really be sure if you had a short to ground, using this Vantage, you could confirm it no problem whatsoever, because as I've just said, it's a straight flat line. It's not moving. Okay, so short to ground. And then yeah, I took the leads off, went away, and now see the noise is, I'm waving it, noise is all over the place. The ghost voltage. Sorry, I'm trying to remember if there's something else I was wanting to say about the Vantage. No, I think that's about it. Yeah, that's about it. But no, you can use a Vantage on it, you know, no problem. It works the same way. It's a multimeter. It's a power graphing meter. You can, you know, see the representation of the voltage, you know, on the screen, and then you can see frequency and other stuff. Later on, I'll probably be doing some more videos, you know, exclusively with the Vantage and the Loadpro, because I've come up with some other neat tricks since I've picked this thing up. So anyway, let me turn this off, and I'm finally gonna get to the operation of the Loadpro, on how it really works, to give you a good explanation. Okay, I'm just gonna hook my leads back up to my other meter here, and by the way, this is Dan Sullivan's meter. It's the TMX 589. I've been using it now for about 6-7 months. I needed an extra meter, and as you can see how dirty it is, I've used the heck out of it, and it's stood up to the harsh environments. I'm pretty impressed with it. Works pretty good, and it's a good bang for the buck. You can I can't remember what it is online, how much it is. You'll have to look up the price. You can find it. All you got to do is just type in a search for it, and you'll find it. So anyway, let's get down to the nitty-gritty here on how this Loadpro works. the Loadpro, it has a, I also drew out a schematic for you. Let me move these, let me see, I think there's 3 of them here. I want them these out of the way. There we go. Now I'll show you what's going on here. Basically what the Loadpro is, it has a 25 ohm resistor in it, okay? And I drew up a schematic, okay, to demonstrate, you know, how it works, okay? So basically how it works is, this is your connector where it's coming to your positive and negative lead of the Loadpro leads, okay? There's positive and negative, okay? Now, the positive feed inside the red handle of the tool. Now, I'm not entirely certain on the exact makeup, but electrically I understand how it works, and this is the best description that I can give you. I'm not sure what type of conductors they're using or what switch, but I can give you a basic understanding of how it works. Okay, so anyway, there's a wire that's connected to this probe, and it tees off. It tees off, and this is the main red positive lead that goes to the meter. Okay, it's going to go all the way through here, probably goes through this square on the leads. Okay, yeah, it goes through the square on the leads, then it goes up to the volt jack. Okay, then you have a switch here, the push button on the handle of the tool. After the switch, you've got the 25 ohm load resistor in it, okay? And the current draw for these, for a 12 volt system, it's half an amp, 24 volt system, it's an amp, okay? So anyway, you've got your load resistor here. The load resistor then goes to the negative side of the wiring, okay? So here's the common side, the negative. It connects down here at the bottom. Then it goes to negative right here, okay? Now, if you notice how it's wired up, without the button pushed, and you go up to a connector, here's that one wire, it's in front of the switch, okay? So you'll be able to see voltage still on the connector without the button pushed, okay? So that's when you know you use the ghost voltage 0 volt diagnosis to understand what's going on. Okay, so if you see ghost voltage, you know, you determine which side the opens in. If you have true 0 volts, you have a short. But then if you see full system voltage, as I've said before, then you push the button on this tool. So then what happens is you push the button, power voltage then flows through the switch, through this resistor, it goes down to ground, and then if you notice and see how the leads are hooked up, when you push this button, the connection for volts is ahead of the resistor on the positive side. Okay, so it's reading ahead of the resistor to the input of it, and then the common is reading on, as you can see right here, the ground, which is the other end of the resistor. Okay, so when you push that button, it is reading the voltage drop across that resistor. Okay, that's how it works. So then if you push the button and you don't get full system volts, say for example it drops down to 2.64 volts. Okay, that's the drop across that resistor. So the voltage drop you see on your meter is the drop across this resistor, and the reason why you're seeing that is because that's what voltage is left over after the resistance that it's already gone through. So like on this example here, I've got it as 100 ohms of corrosion. Okay, so basically it drops 100 ohms of resistance here, and then it goes through the button, and then, or the switch and the resistor, and then the remaining voltage drops across this resistor here, and then it gives you this reading here. And basically this tool, you're using this tool, it's using Ohm's law and Kirchoff's law of voltage drop in series circuits. If you want to know more about Kirchoff's law, you can look it up, obviously Google it, or if you have Dan Sullivan's book, it's on page 65 of Dan Sullivan's Fundamental Electrical Troubleshooting book. Okay, so it works off of those rules. It works off of Ohm's law and it works off of Kirchoff's law. Okay, so as you can see on this, it's 100 ohms of corrosion. I've already written it out. Like on my jump pack, I get about 13.2 volts DC. Okay, so then you to figure out your voltage drops across each resistor, you got to combine the total resistance. Okay, so you've got 100 ohms here. Now, normally you're not going to know off the top of your head what resistance you have in that, but there's a way to figure it out. I'm getting to that. Right now I'm trying to get you to understand what the tool is doing and to better understand what you can do with the tool. Okay, so anyway, you figure out the total resistance, and for this example, you've got 100 ohms of corrosion in this section of the wire. You've got 25 ohms here. Okay, so total circuit resistance is 125 ohms. Okay, so then you use Ohm's law. You got volts over amps and ohms. Okay, so you got 13.2 volts DC. You divide that by 125 ohms. Okay, because voltage on top, if you got one on top, one on bottom, that means divide. Okay, if they're on the bottom, that means multiply. Okay, so 13.2 volts DC divided by 125 ohms equals, I'll just round it a bit, 105 milliamps. Okay, so then you take your milliamperage, which is 105 milliamps. I wrote down 105 or 1,000, I'm sorry, not 105, 1,056. That'd be like 1,056 milliamps, so a tenth of an amp. Sorry, I misread it. So 1,056 milliamps times 100 ohms equals 10.56 volts DC drop. Okay, so then you take the same amperage and then you multiply it by 25 ohms, and then that gives you the voltage drop across this resistor, which is 2.64 volts DC, and that is the voltage that you're going to see on your meter. Okay, so basically that's how it works. It works off of that. Now, to prove my point, I've got a whole bunch of different resistors here from Radio Shack, different resistor values. The first one's 100 ohms, so I'm going to get a 100 ohm resistor, and I'm going to show you that it's 100 ohms. If I can get the camera to focus, that is. Well, hold on. There's another way I can prove it. Sorry. I'm going to go to ohms on my meter. Just a second. Alright, I've got them both. I took some jump wires, connected it to the resistor, positive and negative. I'm reading ohms. And, on the meter, I've got 98.2 ohms. Close enough. 100 ohms. Okay. I'm gonna shut that off. Go back to volts, and then I'll get this set up to show you the voltage drop. Alright, I just reconnected the resistor to the jump pack. It's a 100 ohm resistor. Okay, I've got it connected, as you can see right here. Alright, now my voltage is a little bit lower, so it's not going to be exact, but it's going to be close. So now what I'm going to do is I'm going to load the circuit, and what did I say before for voltage we had on 100 ohms? We had 2.64 volts. Alright, I'm going to load the tool, and I'm at 2.714. There you go. Pretty close. Okay, that's for a 100 ohm resistor. Now I'm going to do 50 ohms. Let me put that down for just a sec. Alright. On 50 ohms of corrosion, the meter is going to read 4.4 volts. Okay? So I'm going to go up here. This is 50 ohms of corrosion. Got 13.12 volts. I'm going to load the circuit. And we have 4.41 volts. There you go. Alright, next resistance. We're going to do 25 ohms. So let me get set up with the 25 ohm. And what I end up doing to make it 25 ohm, I've got these two 50 ohm resistors. I'll wire them in parallel. That cuts your resistance in half, and then you get 25. And for 25 ohms of resistance, I'm going to get, here, let me show you, 25 ohms. You're going to see 6.6 volts drop on your meter. And there you go, 6.66 volts. Okay. Okay, next resistance, we're going to do 10 ohms. Alright, and on 10 ohms of resistance in your circuit, you're going to read 9.42 volts on your meter. So I'm at 1311. I'm going to hit the button. 9.12, 9.23. Okay? That's pretty close. You're going to have some tolerance differences in the resistor. Okay? That's pretty close. Alright? Now, next resistance value, 8 ohms of corrosion. Now I bet some of you are asking, why am I doing so many resistances? And the reason why is I just want to show you on how much resolution that this tool can give you and how accurate it can be. That's why I'm doing this. Alright, I got an 8 ohm resistor hooked up now. Okay. I'm on 8 ohms. The voltage should drop around 10 volts. Okay? I'm at 1310. Hit the button. 9.8 volts. A little bit lower, but you know, I'm pretty close. Like I said again, there you go. 9.78, 9.8 volts. Okay, let off the button, goes back. That's on 8 ohms. Alright, now I want to show you 2 ohms of corrosion. I wanted to do 5 also, but I didn't have enough to make 5. So I had to skip that one. Let me twist these two together. Okay. I've got 2 1 ohm resistors tied together for 2 ohms of resistance. And on this, the voltage should drop to 12.2 volts. Okay. And I'm at 1309. Hit the button. Looky there. 11.99, 12 volts. And if you remember before, we had 13 volts. Okay, that's a volt drop on 2 ohms. Okay, this is it's very accurate. It works very well. You just got to know the resistance values and and what the thresholds are. But this will read a drop down to 2 ohms, no problem. Just got to understand the wiring that you're looking at, current load and everything like that, but that proves it right there. It'll show down to a 2 ohm drop. Okay. Now, say for example, you want to know how much resistance is in that circuit when you test it, because like I said before, when I was explaining this to you, I was just giving you known resistance values. Okay, so say if you go up to a connector and you load the circuit and it drops a certain amount, you're not going to know how much resistance that is off the top of your head. However, there is a way you can calculate it. What you do is you take the voltage that you have at the connector without it being loaded, you take that voltage, you subtract it from the voltage you have on your meter, okay? And then you use that with Ohm's law to calculate how much resistance you have. So say for example on this one here, you've got it's 12.2 volts on the meter. Okay, so you would take 13.2 volts, 13.2, subtract that from 12.2, and that gives you a volt. You know, I knew it was a volt, but I'm just trying to show it to you. So that would be a volt. One volt drop. Okay, so in that resistance, it's dropping the extra resistance in the circuit. It's dropping 1 volt. Okay. So then what you would do is you would take your you take your voltage and then divide it by the amperage, and then that would give you the resistance value. Okay, so but the other thing is you got to think about, well, I don't know what the amperage is of the circuit. Well, that's not going to be hard. All you have to do is you take your the voltage that you have on your meter, take that voltage, divide it by the 25 ohm load resistor, and that will give you the amperage. And the amperage is 0.488 amps. So 12.2 volts divided by 0.488. And there you go. 25, or that's 25 ohms of resistance for that. For that resistor. I'm sorry, I goofed. Alright, it's 1 volt drop. Actually, let me pause this for a second. Just a second. Okay, there we go. Sorry about that. Had to think there for a second. You take the voltage drop of your meter, okay, which is 12.2. So let me put down the calculator, 12.2 volts. You then take that voltage value and you divide it by 25 ohms. Divide by 25 ohms. That equals 0.488 amps. And what did I say the total amperage was for the circuit? 0.488 amps. Now, if you want to figure out what the resistance is of that corrosion in the circuit, you then take that 0.488 amps, you multiply it, or I'm sorry, you don't multiply. You take the 1 volt, I scribbled here, but I was right to begin with, the 1 volt difference from the 13.2 and the 12.2. You take that 1 volt, you divide it by 0.488 amps, and then it gives you the corrosion in that part of the circuit. So take 1 volt, divide it by 0.488 amps, and there you go. 2.04, so rounded down, 2 ohms. Okay, and what did I have down before? 2 ohms. So that's how you figure out how much corrosion is in the circuit. You can do it. All you have to remember is just go by the volt drop that you have on your meter. Take that voltage drop, okay, then divide it by the resistance of your tool, okay, and then that will give you the entire amperage for the circuit. Then you take the difference between the regular open circuit voltage versus the loaded voltage with the Loadpro button pushed. Okay, you take the difference between those two. That gives you that volt. Okay, then you take that volt, you divide it by your amperage, and then that gives you the resistance of the corrosion. Okay, it works really good. It's helped me out a couple times, especially if I was curious about, different circuits, like on a kneeling block. Okay, on a bus where they've got solenoids in it, and normal resistance values for those solenoids are like anywhere from, I think, like 20 to 30 ohms. So what you could do is, if you're not sure if the drop you're seeing is going to cause an issue or not, you could calculate that corrosion and to help you verify to see if it's going to cause a problem or not. So say if you got a 30 ohm solenoid, you calculate the drop and it comes like really close to 30 ohms or a little bit more. There you go. Then you need to find that resistive fault in the wiring to repair it, because you want all of your system voltage to drop at the load. Okay, you're going to have some differences in your voltage, due to the length of wire, thickness of wire, and like that, but the majority of your voltage should drop at the load. Okay, but that's what makes this tool so good. It'll help you diagnose even the advanced level problems even faster too, because you can use the resistance of your tool to calculate the drop in the wiring. Okay, so it does work. It's a cool tool. I use it all the time, and I've said it multiple times. I use it all the time because I like it. So, but anyway, this is how the tool works. It works off of Kirchoff's law and Ohm's law, and if you learn how to understand those two principles, it's going to help you out a bunch, and you'll be a lot better off. But that's how the Loadpro works. It's actually pretty simple, and it works really good. So if anybody's got any questions, comments, fire away. Be more than happy to answer them. One other thing I've said before is, like, I'm a full-time tech, and my time is very limited. If the video is kind of shaky and stuff, I apologize. Or if it's a little bit, with the blur, from the light and stuff on the meter, I'm doing my best. I'm not a camera guy. I'm a tech. So